Hi, welcome to Math Minute. My name is Adam, and today we're going to talk about polynomials. So what a polynomial is a multiple monomials. It's consisting of multiple different terms called monomials. This is what a monomial is. A is a constant, or a coefficient, and n is some power. So this is consisting of three monomials, 2x squared, 3x, and 4. So let's bring this term down, this first monomial, and let's talk about it a little bit. So we have 2 times x squared. A is 2, the constant or the coefficient in front, and n is also 2. So this is our coefficient. And this is known as our power, or our exponent. So let's write power. Now, as I said before, all these were monomials. So this is a little different. This one has very specific coefficient and very specific power. We can see that. This, the power of x, is just 1. Now, n is 1, and 3 is a. We have our coefficient and our degree, or excuse me, our power. Now, this one is kind of hard to see, because we have no x value. But actually we do. We have x to the 0 power. So, x to the 0 power is 1. 1 times 4 is 4. So this is the same thing as right here. So in this case, our n is 0, and our coefficient is 4. Now what we're going to talk about is a little more complicated version of a polynomial. Now this is there's a lot more going on. The powers are different, they're not in order, and it looks like there's some things we could put in between there. Well, let's talk about the degree first. The degree is the highest power of any term. So in this case, let's check all the powers. This is x to the 0, obviously not that high, x to the third, and x to the fourth. Well, the power there is 4, higher than any other power. So the degree in this case is 4. Now the leading coefficient. This is the corresponding coefficient with the degree. So in this case, we go to here. We found already that our degree was 4. So our leading coefficient is the coefficient with that, and that is 32. So the reason this is called the leading coefficient is because if we were given this in this form initially, starting with x to the third, 32x to the fourth, minus 82, we would rewrite this in this form. This is the standard form, where the highest power, the degree, is the first term. And we'll talk about that in a second. Now the last idea is the constant. This is the last term when we organize this with respect to the standard form. So the last term, our constant, is 82. Now this is only when this does not have a variable. If this was 82 times x, then we would have no constant. Our constant would be 0 because there was nothing over here. But in this case, the constant we're adding or subtracting is 82. It's the last value. So now we're going to talk about standard form, and this is where it gets a little confusing because this is just a mess. It's a jumbled mess that's confusing, and what this is saying is that a sub n, these are all constants, these a sub values. They're just constant numbers or coefficients. So now here, our degree was n. So x to the n, then we drop in degree, or excuse me, in power, so we'll have x to the n minus 1, x to the n minus 2, all the way until we get to x to the 1 and x to the 0. So in this case, we said our degree was 4. So we have here, using the standard form, we have a sub n, which is 4, so this is a constant. X to the 4, which is our degree, x to the third, x squared, x to the 1, and x to the 0. So we've applied the standard form idea to this. But where are these terms? We don't have these up here. We just have x to the third, x to the fourth, and a constant at the end. So what we need to do is, these are where the idea of hidden terms come from when we're talking about the standard form. These actually do exist. We just don't see them because our corresponding coefficient is 0. So for both of these, we had multiplied by 0. So this is in the standard form. So although we didn't see it here, applying standard form, we have to account for every value in between from the degree all the way to the end. So that is how we use standard form to understand what a polynomial is. And this is just a way to give us a general idea of polynomials and how we can account for every term. So this has been Polynomials. I hope it's been helpful, and we'll see you next time.